This is lesson 2. This is about Venn diagrams. On Venn diagrams, we'll talk about the notation and eventually we'll talk about the addition law. In Venn diagrams, we use these to display sets of information. There's two symbols we need to learn. The first one here is the upside down U. When an element belongs to more than one group, we read this as an intersection, which means both. If we use the U symbol, which means union, this is when an element belongs to one or another set, or it could be both, belong to both groups. So if we talk about the set A on a Venn diagram, normally a Venn diagram with two pieces of, we have two circles. These circles can overlap. What belongs to A is anything that's in the circle of A, which would be this part here, and including the intersection part with B. So what's in set B is all of that circle of B. What's not in A, that's how we read that, A not. It's anything that's not in the circle of A. So in a Venn diagram there's 4 areas. We can see there's 2 areas belong to A and there's 2 areas that are not in A. The other bit of the circle of B and the outside of both circles. Set not B is everything that's not in the circle of B. There's 2 parts to that, the bit that's in A but not in B, and the bit that's not in either A or B. The next set says the intersection of A and B, so when we see this upside down U, it means it belongs to both. So this area that belongs to both is in the middle here. The next one, A union, means everything that's in A and B. So it includes the 3 parts that make up the 2 circles. Just A and B, and just B. Now this one says it's in A, but, and it's not in B. So it's in A, it's going to be these two we look at to start, but not in B. Well, then it's this section here. The bit in the middle belongs to A and B. So A not B is that section there. Not A but in B will be the B only part of the B circle. Not A but in B. Not A intersecting not B is this area outside the 2 circles. Okay, let's look at this example here. We have a class of 24 students. 10 of these students have at least one parent who was born overseas, 7 students who are fluent in a second language, and 4 who speak a second language and have at least one parent born overseas. So the 2 categories in this is parents born overseas, let's call that B, and the students fluent in a second language, let's call that set L. Displays the Venn diagram. The Venn diagram will end up looking like this. Let's explain how we get the Venn diagram to look like this. There are 24 students in total. We'll come back to that in a moment. 10 students with at least one parent born overseas. 10 belongs in the circle of B. At the moment, you can see it says 6 and 4, but why not 7 and 3, or 8 and 2, or 5 and 5? The reason being is this number 4 here says 4 who speak a second language and have at least one parent born overseas. That means there's 4 who belong to both circles. Because there's 10 students in total born overseas, if 4 are there, then there must be 6 here. 7 students are fluent in a second language. We know 4 also have a parent born overseas, so there must be 3 in this part of the circle because the total language circle adds up to 7. Those 3 numbers we're putting add up to 13, but we're told there's 24 students in total. So there must be 11 students, 24 take 13, who don't have a parent born overseas and don't speak a second language. Alright, we can use this now to answer some questions about probabilities. The first one here says, what's the probability that they have a parent born overseas and they speak a second language fluently? well, this section here. So there's the Venn diagram with just that area shaded. So there's 4 out of a total of 24 students, which we know can be simplified to 1/6. The next one says probability of B union L. That means everything that's in B and L. So on our Venn diagram, it's that areas we're considering. So union means everything that's in B and L. And there's 13 in total out of the total of 24. This one says, what's the probability of not being in L? We'll go back to the original one here. The 6 there is not in L, and the 11 is not in L. So anything that doesn't appear in the L circle, so it's up to 17 out of 24. And the last one here on your sheet, probability not in B, but in L. So that's that part of the circle, not in B, but in L. Not in B, intersecting L. There's 3 out of 24, which is 1/8. These are the questions you need to go and do now. Once again, you should find the first questions up to question 9 relatively straightforward. A bit more challenging questions 15 and 16. Good luck.